So let's use our most expensive tool that we have in the shop to detect whether there is a short on the board. So what we're going to do is pick up the ECM, and we're going to take very expensive tool, this one, and we're going to apply it to the circuit, and we're going to get burned. This chip is shorted. Hello friends, welcome back to the bench. Thank you very much for joining me. Our patient is AM37A, that's 2007 Outback, and you're probably thinking that this is going to be a IC608 resoldering or replacement job, and it's that too, but this one has more than just misfire issues. It does misfire. We have IC608 on board, so that will cause our misfires, but there's other issues. We have P0600 series codes and P0700 series. That means, actually, P0700 is caused by P0600, so we can ignore that one. But P0600, that means that the module has problems communicating with other modules in circuit. They communicate using CAN bus, and that is kind of similar to serial. It is a serial communication, yes. It's actually, yeah, in a way, and not considering the actual electronic side of it, but just the logic side, it works exactly the same. You have a fixed frequency on which you send, but you have one rail to send the data, the TX, and one rail to receive the data, RX. The only difference between the regular COM port in the computer is the actual protocol. It's a differential line. So it's a bit more complex, but basically the idea is that you can connect whatever device to that bus and they can all communicate. If one device on the bus is having issues, it might in turn cause the communication problems between other devices. It might, doesn't have to, but well, actually it's very common that it does. Now, it took me a while to find the transceiver on this one, because typically this chip is responsible for encoding and decoding CAN, and it's typically those two pins over here that are responsible for that, but not on this one. This one is actually, it's 2007. It's kind of like a stepping stone in between two eras of ECMs. So this one kind of has like almost everything from the old ECMs and everything from the new ECMs. So we do have IC608 for injection driving, for driving injectors. We are missing a CAN filter over here, but the CAN doesn't go to the dedicated chip. Instead, we're using off-the-shelf CAN encoder and decoder. So these two pins are the CAN, and these two pins are TX and RX that goes directly to the MCU. So MCU sends data to this chip and receives data to this chip, and treating it like a standard serial connection. On the output of the chip, we have the actual encoded CAN signal in the CAN format. First, what we need to do is see what the CAN signal looks like, right? So we're going to connect the oscilloscope and see what we can see. Also, we will measure the reference voltage, which is not required for this. I'm not sure if it's even implemented here. Yeah, we'll check that out. But what we do want to see is the nice steady signal on the CAN output. So let's see about that. Okay, the ECM is connected. Let's power it on. Okay, we see the first problem. The ECM is grabbing too much power. About 2 watts too much. Maybe a little less than 2 watts too much. We have the CAN high and low indicators on. You probably can see that. The blue LEDs. So we have CAN, and let's check on the scope, and it doesn't look good. That's not, it's not too bad. This could fly, but that's an indication that something is wrong. The CAN signal is choppy. I'll snap it big. As I said, it's not too bad, but it definitely indicates some problem. All that choppiness there. Actually, this doesn't look too bad. Let's grab another one, yeah. So the primary problem here that I see is that it's not dropping correctly. Now, we are connected in between CAN high and CAN low, not between the CAN signal and the ground. So against the ground, or in reference to ground, the signal might be choppy and all kinds of stuff. But as long as it's stable when you reference it in between the wires, right, CAN high and low, it should be nice and square. I mean, there's always going to be some imperfections. It's never going to be a beautiful square, mainly because we also have the wires and all kinds of interference that we're introducing into the circuit. So we expect a little bit of choppiness, a little bit imperfections, but not to this extent. So let's use our most expensive tool that we have in the shop to detect whether there is a short on the board. So what we're going to do is pick up the ECM, and we're going to take very expensive tool, this one, and we're going to apply it to the circuit, and we're going to get burned. This chip is shorted. We could confirm it with a thermal camera, but this tool is a lot cheaper to use, a lot quicker. Yeah, and it's quite long lasting. I've had it for over 40 years. God damn it, now I burned myself. Okay, so that's why the ECM is taking too much power. Is that what causes issues with the CAN? Yes, because in the circuit, like this, we have a linear regulators over here, and those, as the name suggests, are linear, so the more current you pump through them, the hotter they're gonna get. That's why they're attached to the board. They're relatively, well, they're not efficient, they're very inefficient, but on the older ECMs, you saw these on the big heatsink, because the electronics behind it was grabbing a lot more power. Now, as the component production improves, the power consumption reduces, and the requirements for the power is reduced. So this is typically calculated. We cannot supply more current than is actually required with a little bit of margin. So if one of the components on the board is shorted and is grabbing a lot of power, then it's starving other components from that power. And that is why our CAN is chopped. It doesn't have enough oomph to maintain signals, to drop the signals properly, and to actually raising is very good. It's nice and steep when it goes up, but then it has problem. And reducing it, so going to CAN low, the voltage needs to flip, because in this case, when you connect in between two wires, you have positive and negative volt. Now, shall we read the codes from it? See if it actually connects. Let's give it a try. And we have P0607, right? When you do this on the bench, you're obviously going to have a lot of codes that are expected to be there, like circuit high, circuit low, because the engine is not connected. So yeah, it can see the mass airflow sensor. It cannot see the knock sensor, the temperature, all that, right? But P0607 is not what we expect. The explanation of the code, if you Google it, the ECM is experiencing problems such as power failure or memory loss, and thus may not be able to do its job properly. Very nice explanation, very simple. I like it. So that is because of the short. Oh, nice and toasty. Okay, so what do we have to do? To resolve misfires, we need to replace or resolder IC608. To resolve the short, we need to replace the IC402, which is an SE626 chip. So we're gonna take it from this and we're gonna place it on this one. Then we're gonna resolder or replace the IC608 right here. All right, let's get to it. Now looking for the short, and it's gone. 4 watts. Okay, the chip is no longer toasty. Looking good. It will warm up. It is warm to the touch. It should be, but not. It shouldn't be burning. And likewise, the regulators are not as hot anymore either. MCU is warm, like it should be. It's just warm. The ignition coil driver, it's barely lukewarm. That's normal. Okay. Power consumption is correct. Now let's reset the code and see if it comes back. So the ECM was sent here for cloning, actually, not for a repair. But that's pretty common in this business, that customers send you the ECM that could have been just as well repaired. Because typically, you know, that's what you do. Very few people actually repair ECMs. There are some, and better than myself, but there's very few of us. So it's not a common knowledge that you can fix faults like this. This was actually, so this was sent by Nick, but this is for Carlitos. Carlitos? Well, the title, the customer requested that the title is Carlitos car. So that's what the title will be. Okay, initialize, add a scan, and let's clear travel codes. Reset, scan again, read the codes, and the code is we got the standard codes now. So no P0607, was it? Basically power issues. So no more power issues. So to sum up, this chip was shorted. That caused the power issues and the CAN rail issues. This chip needs resoldering, our standard repair, to address misfires. This should be perfectly fine. Oh, I know it. Never mind. But we will still clone it because yeah, why not? Well, we're in, so the reason I fixed it today and not cloned it today is because we don't have the donor yet. The donor is on the way. I in fact do have this ECMs in stock, this exact ones, but I'm not sure if they're H4 or H6 versions. They are not compatible. Like manual and automatic, they usually are cross-compatible because there's an ID pin on the ECM that tells the ECM whether it's an automatic or manual. But if it's H6 instead of H4, it will not work because the pinout is different, the pinout of the ECM. It's slightly different. There's like a couple pins that are crucial that are different, and couple a little less crucial. So even if you connect the H6 to H4 or vice versa, you're not going to break anything. The CAN pins are the same, power, ground, all of that is the same. But some are not, so it will not work. And that is how you repair a weird issue on an ECM. Always wanted to do that. Okay, thank you fellas very much for watching. I do appreciate you. I hope you found this useful. If you have issues with your ECM, hit me up. I might be able to help you or at least clone it for you. I'll see you guys in the next one.